J. Thomson. Electrons. Thomson discovered the electron. During his time, the atom was thought to be not divisible, that it was just a sphere. The atom was thought to be the smallest piece of matter there is. Of course, now we know that that's not true. But that is equivalent to us believing nowadays that electrons are not divisible. So who knows, maybe in the future one of you guys might become a scientist and discover that electron may be divisible. So the atom was thought not to be divisible. So what Thomson did was he ran an experiment. In his experiment, he tested and he found that something based on a mass to charge ratio was 1,000 times lighter than hydrogen. So what could possibly this something that be lighter than hydrogen, the lightest atom already known? So that means this something must be the lightest atom or the new atom not discovered. Thomson ran an experiment called the cathode ray. What it is it has a battery and it's plugged with metals on both ends, and then inside is the gas. The gas is there so we can see the visible beam. On the left hand side is the cathode, that's negative, and on the right hand side is the anode, that's positive. When he turned it on, he noticed that the beam went from the cathode to the anode, from negative to positive. So we figured somewhat that this something was attracted to the positive end. And he noticed that when he used the positive end, it's attracted. The beam is attracted towards the magnet. But when he used the negative ends, it's repelled. So therefore, this something was attracted to positive and repelled by negative. So the beam must be negative. So he changed the metals and he changed the gas. But to his surprise, it still showed the same result. How can it still show the same result? That means this something inside the beam or the beam itself is negative, and it's found in both the atom of the gas and the metal. They're both the same. The question is, what is this something? So now what? So he applied the scientific methods. Well, his observation was it's repelled by negative, so therefore it must be negative, and it's attracted to positive. Okay, we know that. His hypothesis is that it's lighter and smaller than the atom, and it's very negative. So his conclusion is that it's something that's found in all the atom, it must be smaller than an atom, and it's somewhat negative. He called this stuff corpuscle, but it was rejected, and people prefer the term electron. Then he has to make the conclusion about the atom. Okay, so we know these things are called electrons, and it's 1,000 times lighter than hydrogen, for example. So therefore, what can make up the mass of the atom? Are we going to have 1,000 electrons inside one atom to equivalent to the mass? That's not possible then, because then it would be 1,000 times negatively charged. So the charge doesn't balance out. So he came up with the plum pudding model. In the plum pudding model, he has the electron, just a few of them, that would account for the charges, but then there must be a mass that accounts for the whole mass. So this big, huge mass must come from somewhere, and it could possibly be a positive. It has to be positive in order to balance out the negative. And this positive is responsible for all the mass. That way, the negative is only responsible for the charge and not for the mass. Otherwise, you can't have 1,000 electrons. The charge wouldn't balance out. However, later, his plum pudding model was rejected. Wow, poor guy rejected twice. That sucks. I'm sorry, I have good news and bad news. Ugh, I can't take this. What's the bad news? The disease you have? There's no cure for it. That sucks. What's the good news? They're going to name the disease after you. So, if you're going to have a disease named after you, how does it affect your patient?